Hello, everyone. We go on for compound interest, okay? For one more formula. But before we're gonna go for the next formula for the compound interest, I would like to refer to the old one first, the previous formula. Sum, that means the principal plus interest. Interest means of the compound interest, okay? Interest to interest. So sum is equal to P principal, and then bracket time 1 plus R, the whole thing power n. But now I would like to change n as a t. Okay, for n I will change to bt. Okay, to bt. So that means let's see. Okay, so we change n as a t. Okay, t is the number of years. So I will like to write it down at this one because maybe it's better for the next formula. 1 plus r and power 3. Okay, so right now t is the number of years. T represent the number of year. The number of years. Okay, and P is a principal. Okay, P is a principal or the original money you invest. And R still interest rate. Okay, so from this formula, because last example when we do this one, like a for annually, compound annually, right? So in this case, that means one time get one interest. So for last example is what? Principal is a 100. Okay, $100, and rate is a 5%, right? And we do compound annually. Compounded annually. Okay, so when this one, when you use a formula, principal is 100, correct? And 1 plus R is a 5%, so becomes 0.05. And T is a number of years. So they invent this one last time is the example. We do how many years? 5% compound annually. Okay, so that's the formula. So in this case, say if we do the investment do the 5 years, for example. Okay, so this one T gonna be 5, correct? 5 years. That means annually, that means 1 year gonna get one time interest. So then you just time 1 over 1, that's all. Okay, so in this case, so the formula for this one, if I write it down at this one, can cover every condition. So become P 1 plus R. Okay, P1 plus R and R over N. Then N times T. Right now, this formula just say if, because this one, in case they invest by compounded, they have many conditions, right? Annually, semi-annually, monthly, or weekly, or daily. Okay, so this formula will cover all. Okay, so become P times 1 plus R over N, the whole thing power N times T. So in this case, N will represent N gonna be the number of compoundings per year. Gonna be the number of compounding per years. Okay, and T represent the number of years. P principal still the same as the interest rate. Just say how many percent, something like that. Okay, and sum, this means the total when end of 5 years, what the total amount plus the interest gonna be. Okay, so now this is one formula. We get this one now. Now next, how to get the formula for the continuous compounding. Okay, so then we're gonna get this formula to get the formula for continuous compounding. So this is one formula we have. So I write in the box first. Okay. Okay. So then because of this one, if in this case, see, if we let the number of compoundings n, this n, right? The number of compoundings per year increasing without bound, just keep increasing, like you see this table, right? And then this one, if the n is increasing and increasing, then we call this one as a continuous compoundings. So we're gonna, so in this case, we want to get this formula. So if say we let m, for example, m equal to n divided by r. N is the number of compoundings per year, and R is the interest rate. Okay, for in this case, if I simplify it, N equal to M times R. Okay, so I replace N in the formula. Okay, so final S here gonna be P1 plus R, N equal to M over R. Okay, and then the whole thing N equal to M power R times T. Okay, from this one, R cut, where we can simplify, become 1 plus 1 over M and power M R T. So in this case, I can simplify by using this exponent, right? Can use the exponent formula plus 1 over M, and then this one power M, and I like the index, this is a whole thing outside. This one power R power T. Okay, then after this one, come back to this one, the table. See, this table I used to refer when we learn logarithm, about the natural logarithms. I explained about the value of E, right? Natural logarithms, this mean base E. And then we know E equal to 2.7182 something. Okay, that is from this table. Okay, so then you can see from this, if 1 plus 1 over M, the whole thing power M. 1 M is one M increasing, one M increase is increasing without bar, right? So you can see the table on the left here. They will show this, the whole thing when say is M equal to 1, then you replace 1 here and the index. So you got 2, correct? And if M equal to 10, then you replace here denominator and the power here index. Can use calculator. This one gonna be 2.5937 something, and so on. If you replace M to 100 equal to 100 here, and index 100 gonna have 2.7048 and so on. 1,000 replace it, and 10,000 and 100,000. So if M increasing without bounded up to infinity, then you can see final this 1 plus 1 over M power n gonna equal to 2.71828 and something up. Then they name this one equal to E. So this value of E is come from this definition. So then we know E equal to approximate this one. Okay. So this is the whole thing here. You observe this is the whole thing here. Then final equal to E, which is equal to 2.71828. And then you see this one, the whole thing here is an E, correct? It's an E. So we can rewrite it down, P times E power R T. So this is the formula of continuous compounding. Okay. So this is a formula of continuous compounding. What the meaning of this one? Continuous compounding is like when you invest, you get the interest right away. Okay, they will, and actually this one will provide more, will provide earning, right, more than another way, because they keep this final balance will larger than another, will larger than compounding in time per years. Okay, in time per year. So then I will explain for example for how to use these two formula. Okay, so far compound interest, we have two formula to use. Okay, first one is n compounding per years. This one, this is the n compounding per year, and the second one here is the formula of continuous compounding. So S equal to P E power R power RT. Okay, so and the definition for each alphabet is here. T is the number of years, P is the principal, R is interest rate, and N is the number of compoundings per year. Okay, and E, we know E equal to 2.71828 something. Most of the time we use only 4 decimal places. Okay. Okay, so now I will stop right here first, and next I will give you the example how to use these two formulas, which is regarding about the compound interest, and this is going to be your SAT also. Okay. Okay, so see you next time. Bye.